All right, today's notes are called Application of Exponents to Metric Conversion. Here's our learning target for this lesson. I can use exponents to name powers of 10 for metric conversion. All right, let's do some quick review with our place value chart. So we've got some colored discs in the place value chart, and we're just going to convert those to a number and a word name. So we're going to put 3 in the tens, 2 in the ones, and 4 in the tenths. So our number is going to be 32 and 4/10. Now let's take 32 and 4/10 and multiply it by 10. Remember, when we multiply, we're moving to the left on our place value chart or board or mat, whatever you want to call it. So now we have the number 324. If we want to divide by 10, we're going to move to the right on the place value board. So our number becomes 3 and 24/100. If we want to multiply by 100, we're going to move 2 places. We'll need to add a 0 for the placeholder, and their number now becomes 3,240. Dividing by 100 is going to move us 2 place values to the right. And so now our number is 324 thousandths. If we have 837 and divide it by thousandths, 1, 2, 3, 1, 2, 3, 1, 2, 3 places. So now we have 837 thousandths. All right, so let's do a little review of writing units as decimals. If we have 9/10, we're going to write that with a decimal point and a 9. Standard form 10/10 is actually going to be 1 whole. 20/10 is going to be 2 wholes. 9/100 is going to look like this. Just a quick reminder that you should be copying all these down in your composition book. If you're not, you need to go back and get these examples down. 10/100 is actually going to be 1/10. We can put the 0 behind it, but it doesn't have to be there. 11/100. 9,000ths is going to look like this. 10,000ths is going to look like this. 20,000ths. 64,000ths. Now, a quick review from yesterday about writing an exponential form. We're going to look at how many zeros follow the number, and that's going to be our exponent. So in this case, 100 equals 10 to the 2nd power. And that's not 10 times 2. It's 10 times 10. 1,000 is going to equal 10 to the 3rd power. 10,000, 10 to the 4th power. 1,000,000, 10 to the 6th power. All right, so let's talk about conversions within metrics. And I hope that you learned last year the acronym King Henry died unexpectedly drinking chocolate milk. So this is for milli, centi, deci. These are the units, which are meters, liters, and grams. This is deca, hecta, and kilo. Okay, so all we're having to do is move our decimal point either to the right or to the left based on how we're converting. So if we're going to start here at kilometers or kilometers, whichever you want to say, and we're going to try to move here to meters, we're going to go 1, 2, 3 spots to the right, and because we're going to the right, we're going from larger to smaller. We're going to be moving our decimal point we're going to be moving our decimal point to the right. So if we've moved 1, 2, 3 spaces, we're going to need to add 1, 2, 3 zeros. So 1 kilometer is the same as 1,000 meters. All right, let's try the same thing only with grams. We're going to start at kilograms. Move 1, 2, 3 places to the right down to grams. So we're going to add 1, 2, 3 zeros. So 1 kilogram is the same as 1,000 grams. And now we're going to do the same thing, only we're going to be moving from liters here down to milliliters. 1, 2, 3. So 1 liter is going to be the same as 1,000 milliliters. Now we're going to convert from meters right here to centimeters. 1, 2. So 1 meter is going to be the same as 100 centimeters. Converting from meters to millimeters, 1, 2, 3. So that's going to be 1,000. Right, let's try a problem solving using money. Mr. Brown wants to withdraw $1,000 from his bank in $10 bills. How many $10 bills should he receive? So we're going to divide by 10. That means we're going to move to the right on our place value chart. So he's actually going to get 100 $10 bills. How many centimeters are there in 2 meters? So if we're going to start here at meters, 2 place values to the right. So there are 200 centimeters in 2 meters. So that asks the question, how can the same line be 2 meters and also be 200 centimeters? And that's all because of conversion within the metric system, because of the label. Meters and centimeters are not the same, so that's why their numbers tend to be different. Can you represent the conversion from meters to centimeters using exponents? So if we take the previous problem, 2 meters equals 200 centimeters, we could also say that 2 meters equals 2 times 10 to the second power in centimeters, because 10 to the second power is 10 times 10. 10 times 10 is 100. 2 times 100 is 200. All right, so let's bring a fraction into it. What fraction of a whole meter is 37 centimeters? So if we're going to take our mnemonic, start at centimeters and go to meters, 1, 2. So we're going to move our decimal point, 1, 2. So 0.37 or 37 hundredths meters is the same as 37 centimeters. We can also write that as a fraction of 37 over 100. All right, let's show the conversion using from 1.37 or 1 37 hundredths meters to 137 centimeters with an equation using an exponent. So if we look, we've moved the decimal 2 places to the right, which means we've multiplied by 100. 100 in exponents is going to be the same as 10 times 10, which is also going to be 10 to the second power. So 1 37 tenths times 10 to the second power equals 137. All right, another problem solving. The baker uses 6/10 of a liter of vegetable oil to make brownies. How many milliliters did he use? So if we go from liters to milliliters, 1, 2, 3 to the right, we're going to move 1, 2, 3 to the right. We're going to put our zeros for placeholders. So 6/10 of a liter is going to be the same as 600 milliliters. Okay, back to the baker. The baker uses 6/10 of a liter of vegetable oil to bake brownies. He's asked to make 100 batches for a customer. How many liters of oil will he use? So we've got 6/10 times 100. We could also say 6/10 times 10 to the second power, but it's still going to come out to be 600 liters of oil. All right, after gym class, Mei Ling drank 764 milliliters of water. How many liters did she drink? So let's go 1, 2, 3 to liters. So we're going to move our decimal 1, 2, 3. So she drank 764,000 liters of water. Right, let's convert 1,045 milliliters to liters. King Henry died unexpectedly drinking chocolate milk. And our unit is liters right now. So if we start at milliliters and we're moving 1, 2, 3 places back to liters, then we're going to take our number 1,045 and we're going to move our decimal to the left 1, 2, 3 places. So 1,045 milliliters is going to be equal to 1/45,000 liters. All right, we're going to go from liters now to milliliters. 1, 2, 3. And we're going to take our number and we're going to also go to the right. 1, 2, 3. So 8,000 liters is the same as 8 milliliters. So now we're going to convert using an equation with an exponent. So we're starting at meters and we're going to centimeters. That's 2 place values, so that's times 10 times 10. So 3 times 10 to the second power is going to equal 300 centimeters. Take 900 centimeters and go to the meters. We're also going to move 2 places, which is going to be 10 times 10. So because we're moving from smaller to larger, we're going to have 900 divided by 10 to the second power. So 900 centimeters is the same as 9 meters. Okay, now let's try this one. 8 1/10 liters to milliliters. 1, 2, 3. Oops, I forgot to change colors. So it's 10 times 10 times 10. So 8 1/10 liters times 10 to the third power is going to be 8,100 milliliters. 537 milliliters to liters. 1, 2, 3. So we've got our 10 times 10 times 10. Because we're going from smaller to larger, we're going to be dividing 537 divided by 10 to the third power is going to be 537,000 liters. So we have 90 5/10 kilometers. We're going to multiply that by 10 to the third power to find out how many meters we have. It's going to be 90,500 meters as opposed to 90 5/10 kilometers. And for the next 3 slides, I'd like you to work these in your composition book and be prepared to talk about the correct answer with me tomorrow when you come to the teacher table. All right, so in this problem, 3 5/10 kilometers, we can rewrite that to be 3 kilometers and 5 meters. 1 2300 liters is going to be 1 liter, 23 milliliters, excuse me. 2 2,000 kilograms is going to be 2 kilograms and 2 grams. Work the next 3 slides problems on your own. Be prepared to talk about them tomorrow during class at the teacher table. Remember, you can stop the video and work through the problem in your composition notebook and then restart it up again to move on to the next problem. All right, problem solving. The length of the bar for a high jump competition must always be at 4 7/75 meters. Express this measurement in millimeters. Explain your thinking using an equation that includes an exponent. So let's go back to our mnemonic. King Henry died unexpectedly drinking chocolate milk. We start at meters and we're going to go to milliliters. Millimeters, 1, 2, 3. That's going to be 10 times 10 times 10. So, because we're going from big to small, 4 75/100 times 10 to the third power is going to equal 4,750 millimeters. A honeybee's length measures 1 centimeter. Express this measurement in meters. So we're going to move 1 2 places, which is going to be 10 times 10. So 1 centimeter is going to be divided by 100, or 10 to the second power. So 1 divided by 10 to the second power. So that's going to equal 0.01, or 100th meters. All right, you need to work the next 2 practice problems on your own in your composition notebook, and then you're going to finish up with the 4 exit ticket problems that will be on your quick check quiz when you come into math tomorrow. Good luck. So this is your last exit ticket problem. Finish this in your composition notebook. Be ready for the answer in your quick check quiz tomorrow. Congratulations, you've finished the last video that you need to watch for this week's math.